Yeah, thanks for the intro. Yeah, very excited to talk here today. So, yeah, let's start. Like, so how do I do? So, first is a quick disclaimer. So, I'm not a security expert, and I'm not a systemd expert, which I used a lot for this, and I'm not a networking expert. But I'm an engineer that had a problem to solve, and the things I show you here that work for me very well, also in a production setup. But if you kind of adapt this, I strongly suggest you to kind of poke into it before you adapt this for yourself. Yeah. So, who am I? I started as a backend developer and did a long journey then to via kind of deployment automation in various systems, and moved all around the stack, like doing even front end in AngularJS, as I said, backend in the various different languages. No Golang so far, so and I have a strong interest in distributed systems and making all this work, and also in continuous delivery. So all this led me kind of to this position as a DevOps engineer, even if I really don't like the term DevOps if it's related to a position, because I think it's a philosophy that should be adapted throughout the company, and it should be at all levels. So. I started using CoreOS one year ago, and the immediate problem I had to solve that I was in an environment where I couldn't trust the network. So I had bare metal machines in a multi-tenant network, and so I immediately wanted to have some kind of security, a network layer. The alternative is, of course, to use TLS everywhere on every application, but since we had a lot of old things to run, I kind of was a bit resilient to kind of enforce this everywhere and wanted to be able to trust the network. And then I looked around, and at this time, Project Color I think wasn't even at this thing. We've had no encryption when I started, and also Flannel had no encryption. So I was looking, I kind of had to do my own thing, and it was also my first kind of pilot to run a thing on top of CoreOS and kind of get into the whole tool set. So if we look at this is the diagram from the Flannel documentation, and the main problem is on the right side, the packet is running unencrypted over a network. And what I wanted to achieve is something like this, which looks quite similar. It's actually almost the same diagram, but I replaced the Flannel daemon by the Tinc daemon. And then, the encrypted, the packet is running encrypted over the untrusted network. So, how do I do this? I used etcd, Flannel, and Tinc. Some shell script building blocks. Put all of this together in systemd units. I show you all this, then I talk a little bit of the performance, and I'm happy to answer all your questions if I can. So I guess you all know etcd. It's the configuration store for CoreOS clusters, and I use this to distribute the VPN configuration across the cluster. etcd supports TLS, so I recommend to kind of set it up in a way that you can securely talk to etcd. If it's only regarding the VPN config, it's probably also working without, but because there's only the public keys in the etcd key store. But yeah, anyways, I would kind of recommend to set it up in a secure way. Yeah, so like there is a lot of handy commands like with etcd-ctl provide. So I would use the namespace like services tinc, and in there's a configuration file for every host in the network. So yeah, you can get the configuration file, like which is basically the public key and so on, from etcd. You can kind of write the configuration to etcd, which I do with the time to live. So for now, kind of the key for every host expires after 60 seconds, and I rewrite it shortly before expiring. So like if a host goes down, kind of the key would not be written to etcd anymore, and it would kind of disappear from like the VPN. Yeah, and in the end, if I kind of go down in a controlled state, I would kind of remove the key from etcd. Most important thing is etcd-ctl watch. Like I recursively watch this services tinc namespace, and then call like a script with the changed values. So the basic thing is the key. Like you get into the script in an environment variable and then the changed value. So we look into this later, and unfortunately these don't seem to fit on the page. Yeah. So yeah, then Flannel. Flannel is a Chorus project. Like here we heard the news that it kind of joined forces with Project Calico into Kernel. So yeah, might be a bit outdated my talk regarding this, but like when I started, all of this was not happening. And I still think it's a valid approach to do this if you need network encryption, because like for now, Calico or Kernel, Flannel is not providing this. I use Flannel only for the subnet allocation. So there is a special backend called alloc, and it would just allocate a subnet for your host, and I write it into an environment file. So, and then I can read this and configure the VPN accordingly. So Tinc VPN. Why did I use Tinc VPN instead of something else? So basically, the nice thing for me, beside that is it's open source, and it's doing encryption based on standard libraries like libSSL and libcrypt. It has a daemon which you can talk to and which can do everything for you, also the configuration. So you don't need to touch a configuration file. You can do all the configuration via tinc daemon commands, which kind of makes it very nice and easy to automate this thing. Yeah, so let's look a bit into those commands. So like I can do a tinc init, which provide which will generate a private key and a public key pair, and like do the basic configuration. If I kind of reconfigured Tinc on the file system, I can kind of tell the daemon to reload the configuration. I can add hosts to the VPN by calling tinc connect to. Of course, the other configuration files for this host has to be on the disk if you do this. I can configure the subnet, and I can configure all the other properties of the VPN. So in this case, like the device, the mode. So I wanted to run in a switched mode. And what Tinc will then do, it will create a fully meshed overlay network on top of the kind of hardware network. So Tinc on CoreOS, so Tinc daemon and also every configuration command is running in a Docker container, and I kind of bind mount etc tinc, like etc tinc in the container as a bind mount to a kind of directory outside of the container. In my case, it's /serve/tinc, and then kind of it needs to use host networking, and it needs to have the net admin capability. Yeah, and that's it. Then it's working. Yeah. So this is my kind of main loop. So I, like, while the Tinc service is running, I kind of write the configuration file containing the public key and IP address data of the host into etcd, and then I grab it up on the other hosts. So yeah, let's see if I have a quick look on this gets. Yeah. So, like this is a gist on GitHub containing the most important configuration files. As I said, I'm not a systemd expert, so there is probably a lot nicer way to do kind of this, like waiting for an interface and bridging it to another interface. So, like, bear with me if this is still in the state. I just made it running, and then I kind of focused on other problems. So, yeah. Then here's this configuration updater service. So this is watching etcd for updates and calling the conf updating script. Then there's yeah, like a thing that waits for the Flannel to create the subnet and and so on, and creates an environment file for Tinc. Then finally there's the Tinc service, which is kind of running as Flannel on the early Docker service. So I started up in the same phase as Flannel, and then kind of before it starts up, it kind of runs some in exec3 some Docker commands to do the initial configuration we talked about, and yeah, so and then it runs like in the main loop the etcd. No, in the main loop it constantly updates the etcd key with a TTL to kind of show that the host is still alive in the VPN. So this is the main control loop. So I watch like the script called by etcd watch, and so it will kind of be called if there's a change, and then what I do, I compare the changed value to what's actually on disk to kind of avoid unnecessary loads of the VPN daemon. So, but if there is a change, then I kind of write it to disk and just reload the thing. So yes, I think that's a quick walk through the scripting. So what does it look like then on the host? So there's so this is kind of the view inside the container. So there's a private key, and a configuration file and the individual host configurations file /host. So also the configuration file for the host itself is there. And then there is the Tinc configuration file for the Tinc daemon. So this is how the Tinc configuration file looks like. So this is grabbed from one of the nodes in the cluster. So as I said, there's no need to kind of write these files. The Tinc daemon does it for you. And then there is a file for each individual host. So you have the public key there, and you have the public available internet IP there, and then you have the subnet for which is assigned to this host. So like, let's talk about the performance of this thing. So I kind of yesterday did some tests on a cluster. So this is a 5-node cluster with a modern Intel CPU. It's having 46 gigabytes of RAM. I don't think this is important in this context because, like, on such a small cluster, Tinc wouldn't use a lot of RAM. And it has a fully switched 1 gigabit network, and it's running Cora stable, like latest version from the stable channel. So I did a kind of performance baseline, which kind of so I used iperf for this, and without the VPN, I'm having a throughput of 934 megabits a second. Well, then if I run the same in the Docker container, which is then kind of in the VPN network, the throughput drops to 866 megabits a second. So I think I lose about 15 to 20% probably, which is, for my workload, okay. I mean, everybody kind of needs to decide this on their own, if he can live with this performance drawback, or kind of has to do some other trade-offs regarding security. So if we look into this, yeah, this is taking from Heapster. So you see, like, I think this spike in networking was the small test you've seen there. I've run another test like for a minute or so to kind of make it more visibly what's happening. So this, I think the scale here is megabytes per second. Yeah. And then regarding the CPU consumption, like while the test running, like while this is running, Tinc takes like about 70% of one core, which is, for me, like, if it's, in this case, it's really doing a lot of traffic. So in this case, I think it's quite okay. But again, like, this kind of depends on your workload, if you can spend CPU cycles on this. So here you see the CPU usage in the cluster. So you see that, like, the hosts where, like, the client and the server were running are having a spike here. Yeah. So, yeah. So, yeah, let's talk about the scale of the thing. So, from the Tinc documentation, I have read, I've understood that there is no limitation to the actual size of the VPN, like in Tinc itself. There will be kind of other limitations because kind of every node in the VPN takes a small amount of RAM, and also you need some file descriptors for all the configuration files, so you may kind of run into some limits there. So I'm happy to answer questions if I can. So, yeah.
Two questions. One is, do you have any kind of performance metrics to get anything beyond your local network? And then being over the internet. And then the on anything more than 1 to 2 gigabits a second on encryption?
Oh, so no, like I have nodes across data centers, but the data centers are really close together, so it's basically probably some kilometers with a kind of really good connection. So I don't know if this counts for over the internet. Theoretically, Tinc is built for this, but I can't tell. And now I personally have only experience with my cluster, and it's not that big, and it's only like the Intel hardware there.
So just the principal question, why would you run a VPN inside your trusted data center?
It's not a trusted data center.
So you basically have a shared...
Yeah, the network is shared. And the other thing is, like, even if you're in like your trusted data center, I think even Google is now doing TLS everywhere because they basically, because of all the stories, can't trust the network in certain ways. So, yeah.
A lot of hosting providers have shared backend
Yeah.
across many customers.
Yeah.
One side remark, even if the data center looks like a data center, it can consist of several buildings with public fiber between these buildings, and this public fiber can be from completely different operators. So even if it's an Amazon data center, you see this sometimes on slide 55 in Amazon telephone. There might be fiber which is not owned by Amazon between buildings. So even if it's in the same data center, this applies to all data centers, there might be an outside connection which is not protected. So this makes total sense, even in the data center.
Yeah.
So in the end, we will have none of the three four machines between each other, like the mesh. However we go, we will have this. Or
Yeah. Basically, it's working in the same way as Flannel does. So if you boot up a new machine, it will kind of put the key into etcd. The other machines will recognize it, pull down the configuration from etcd, reload the VPN daemon, and you will have the machine in the VPN, and you have a fully meshed VPN between those machines. Yeah. So for me, it really kind of worked surprisingly well. Like when I put this together, I was a little bit scared because all of the kind of new technologies like etcd and like the scripts involved. But in the end, I was running it on the production cluster, and it survived every reboot of CoreOS very well. It was like for now to now, like never failing. Yeah, of course, this is no guarantee, so you have to kind of look into this yourself. Yeah, so you can see like a small vagrant playground using this in my GitHub account. There's also tons of other stuff regarding Kubernetes. So, for example, I set up my clusters with a custom solution because when I started to use these bare metal clusters, there was like nothing available. So I had a solution using Ansible. So it's also there. Yeah, so if you want, have a look and kind of give some feedback. So thanks for listening. Thanks for having me here. I hope you enjoyed. Ja? War gut?
Genial. Ja, ja, fand ich sehr, sehr gut. Die Kollegen von QS waren sehr interessiert.
Ja. Hey. Hi, hallo.
For the interview.
That was you. Yeah, okay. Yeah, nice.